Hi everyone. In response to some questions and comments I got during our very first lab, I wanted to show you a few things about JLS that I think will help out and make this next lab go a little smoother. So the first question I got a lot was how to set up wires. So let me add a couple of gates here, maybe an AND gate and an OR gate. And now the way I typically do wires is I right click and select wire from the context menu, and then I click on the start and I drag and I click on the end. Now sometimes you might want to put a wire in without having a destination in mind yet, so you can right click, select wires, click on the beginning. And let me also point out that your wires don't all have to go in a straight line. So I can go over and click and go down and click and go over and click. And now if I don't have something to hook it up to at the end and I just need a placeholder for a minute, if I right click, that will release the wire. There's other things you can do as well. So if I'm going to put a NOT gate in here, for example, I can just connect something directly to that wire and then move it around. Similarly, if I grab another gate here, I can take that gate and drop it right on top of the NOT gate, and then if I spread it out, the wire shows up. If you didn't notice in that context menu, there are key shortcuts as well, so Control W will start a wire, among other things. If you right click and look at that context menu, you can see the different control combinations that are some key shortcuts there. Now let me clear this out. The next thing I want to show are subcircuits. So just like you can write functions with code and call functions multiple times so you don't have to cut and paste code all over the place, you can do the same thing in JLS with a subcircuit. So let's say we're going to build a half adder here. So I'll have inputs A and B and output sum and output carry. All right, now if you remember, the sum is just an XOR. So notice I'm going to drop the XOR right on that sum and then slide it back out. Use the right click for the wire. Use the right click for the wire. Right angle wires look so much nicer than diagonals in most cases, not all cases. Put an AND in here. This one I'll connect just by sliding it over. The other one I'll connect more typical way. All right, so we have a half adder. I'll do this. I'll do a save as. I'll save this as half adder 1. Now let me go to create a new circuit. Let's say this one's a full adder, so we'll have an A, a B, and a carry in. Now one way to make a full adder is out of 2 half adders. And so if I want to do that, if I want to use that half adder twice, I can go to File, Import, select that JLS file. I have to give it a name. We'll call it half adder 1. And now I have that black box with the half adder in it. And I can wire that up to my A and my B. And then I won't need a second half adder, so I'll go back to Import. I'll select that half adder again. I have to give it a different name. That's why I have to give it names so you can tell the two apart. And so this time we'll take the sum and the carry in. And you see what's going on here. So you can save your parts and import them multiple times so that you're not cutting and pasting. Now, if you ever need to take a look inside, if I just right click on the half adder and go to modify, then I'm now looking inside that circuit. I can even modify that circuit if I find a bug. Now, once you import a circuit, though, it is like cut and paste. It isn't like code where it's all referencing the same underlying code base. So if I make a change here for whatever reason, so I'll cut that and put an OR gate in just to demonstrate. And then I can close that subcircuit. I'm back up at the top level. If I look inside my other subcircuit, it hasn't changed. So when you import a circuit, you are cutting and pasting it, and you get separate copies of each subcircuit you import. Now the good news is that you can then customize them. You can go into the individual ones and make changes if you need to. The bad news is if your original has a bug in it, then you either have to go into each of those subcircuits and fix the bug, or let's pretend there was a bug here in that half adder circuit. There isn't, but just for sake of argument, I'll put that NOR gate there, and I'll save that. And let's say in here that's the version I needed. Then I would have to go and delete all my subcircuits and re-import them. So the lesson here is, as you're building your adder or other circuits as part of the 351 projects, test your subcircuits before you use them. Because if you build them and you don't debug them first, and then you use them all over the place, when you find the bug, you have to go rip them all out and re-import them, and that's certainly not any fun. The last thing I want to point out is, let's look at the AND gate here. You see that there's two things up top. There's inputs, which is the number of inputs, and the gates. So if I change the inputs to 5, you see here that I have a 5 input AND gate. But if I instead change the gates to 5, what that means is I am now taking as input 2 5-bit buses. What I've really built there is 5 AND gates that all run in parallel. So you'll notice if I try to hook this wire up, it's going to complain. It's going to say bits don't match, if you see that in red up at the top. That's because I'm trying to hook a 1-bit wire to a 5-bit bus. In contrast, if I were to create an input called test with 5 bits in it, it will let me connect that the way you'd expect. And the reason I point this out is if you have a set of wires where you need to do an AND on all the pairs of those wires, you don't actually need to make separate AND gates. You can create all of those AND gates as a group by choosing the gates input here. Okay, I've got an idea. Let me show you the answer to problem 14 on the homework. So I'll clear this stuff out. And so let's say we have two 6-bit numbers. So we'll call them input A and input B. Notice again, these inputs are 6 bits wide. And we want to figure out if A and B represent the same value. So what you saw in the homework is that you wanted to do an XNOR gate on each pair of wires. So A0 XNOR B0, A1 XNOR B1, and so on. Now I could certainly do that by grabbing this XOR and making 6 different copies of it. I won't finish that out. And then I could take this and I could split it up, or unbundle it rather. And then I could hook this one to 0 and hook this one to 1 and so on. But that's the long way. You don't want to do this. Let's get rid of this. What you want to do instead is create a bundle of 6 parallel XNOR gates. So instead of having to build them all separately, we'll take the 6 wires and put them in there. We'll take the 6 wires and put them in there. And what it's going to do is it's going to do an XOR on A0 and B0, and A1 and B1, and an XOR on A2, B2, and so on. And then, of course, this is XOR. We need XNOR, so we can do the same thing. Take 6 parallel NOT gates and apply them all at once. So now this right here where the cursor is 6 wires, and each wire tells you whether the corresponding bits are the same or not. Now to know if the values for all those wires are the same, then we need to put an AND gate on all of that. So at this point, then we'd have to get out that unbundler. So split it into the 6 individual wires so we can use a single 6 input AND gate. Notice there's just one AND gate there with 6 inputs, because now we're not doing this in parallel, but we are doing an AND of all 6 wires. So those are a few things that I think will help reduce the time to complete Lab 3 and the Project 1. Let me know if there's anything else I can clarify or anything else I can do to help you along.